Hi, this is Andrew Rafferty. This is my Chapter 7 presentation on dimensional analysis and reconciling units. I don't think I'm the only one in Chapter 7, so please bear with me if this seems a little repetitive. So an overview of the chapter. These are basically just problem-solving techniques used to assist engineers, or in our case students, in solving mathematical equations. We stress this over and over and over again in our high school chemistry class, how important it is to take your time, make sure that your units are correct, which is really why I wanted to choose this unit. So start out, Messler had a couple of definitions in there. The one part that I took out from it was that dimensional analysis should be used to check that an equation has been written correctly. Again, if you check the chapter, there's a couple other definitions, but this was a short and sweet applicable definition for my class. And then his definition for reconciling units is that they should be used to yield the needed or desired units for the solution to an equation from the input parameters. And then I put in bold, often requiring the use of conversion factors, because we spend almost 2 full weeks in college prep chemistry just worrying about converting from different units. So the first example I have for dimensional analysis in a high school chemistry classroom would be our universal gas law. We actually talk about Tom Brady and the Patriots when we bring this up, because this is one of the equations that they use to determine whether or not Tom Brady was or was not a cheater. I'm an Eagles fan, so of course I side with he was a cheater. But the universal gas law is PV equals nRT. In this equation, pressure, or P stands for pressure, V stands for volume, N is moles. If you aren't familiar with what a mole is, it is just a large number. It refers to 6.02 times 10 to the 23rd of something. So you can have, just like a dozen is 12 of something, a mole is 6.02 times 10 to the 23rd of something. And then temperature has to be in Kelvin. In this equation, R is a constant. Where the trouble arises is that on the formula sheet that we give the students, there's actually two constants two constants that are R. Let me move on to the next slide. So on their formula sheet, you can see that R can either equal 0.08206 or R can equal 8.3145. So this can be confusing for some students, especially on the day of a test if they're not sure exactly which one to use. And if you use the wrong one, you will get a completely different answer. So if we go back, actually, you can see that since we have R is in the units of atmospheres, liters over moles times Kelvin, then the R constant that we want to use is 0.08206. And we're going to show how students can figure that out just by using dimensional analysis. So first thing students will have to do, and this is the first thing that we make them do in every equation, is rearrange the formula. So if you want to find out what you should use for R, you're going to have to solve that equation for R. In order to do that, you have to divide N and T to both sides, giving you PV over NT equals R. If you know that the units for pressure, volume, moles, and temperature should be atmospheres, liters, moles, and Kelvin, which students should be expected to know, then you can figure out that, well, my R must be 0.0826 and not 8.3145. If you're an elementary teacher, this might seem a little confusing, but hopefully my next example can help clear this up. So at the elementary level, we're not really, I would imagine, not asking them to rearrange formulas, especially dealing with stuff like moles. But I think the key here will be for students to understand what certain variables they are measuring, and then to know what units fall under what category. So if they're dealing with length, they must know that that is a distance from point A to point B, and they should know that stuff like miles, inches, feet, meters, kilometers deal with length. Another example I had is volume. And this is something that we see at the high school level, that students do not know what volume, density, mass is. But they should know that is the amount of space something takes up. So we can measure liquids in volumes of liters and gallons, or even some solids in tablespoons. And if you want to find like the volume of a room, you would do a distance cubed. So if I want to find the volume of a textbook, I would do length times width times height to get me centimeters cubed. So I was thinking, what are some problems that the kids could answer on their step 2 using dimensional analysis? So if they want to fill in the blanks here, so it'd be like, I should measure my height in feet and or inches. York is about 30 miles from Lancaster. My textbook is 3 inches thick. The swimming pool has 20,000 gallons. And our classroom has a volume of 14,400 cubic feet. Again, this might be a little high for the elementary level, but I'm sure that you could change this up if you needed to. Now, for reconciling units in high school, we do 2 steps here. So we start off the semester with factor label. So that's just converting between units in the metric system, because that will be a consistent step that they need to do in solving any sort of problem that we have. It's basically getting them ready for stoichiometry, which we hit in the 4th or 5th unit towards the end of the semester. And stoichiometry is just where we use balanced chemical equations to convert from mass, volume, or amount of particles, which we call moles, and between different substances in a reaction. And I'll have an example for you. So for factor label, this is like literally first week of our class. So if they want to convert 0.324 kilometers to meters, they would first need to know how many meters are in a kilometer. So you can set up the problem like 0.324 times, and then I have 1,000 meters over 1 kilometer. The reason we set this up like this is so that the kilometers can cancel out, and then you should have just meters left over. Multiplying 0.324 kilometers by 1,000 meters over 1 kilometer is the same as multiplying it just by 1, because 1,000 meters equals 1 kilometer. So we're not actually changing the value that we have, we're just changing the number and the units. So a more complex example that we get to would be converting from something like kiloliters to centimeters cubed. And if the students have to memorize certain prefixes in the metric system, like knowing what like mega, nano, micro, centi, deci, what all of those stand for in terms of amount based on the base unit. So once they get comfortable with factor label and they get to know the different elements, ions and compounds, we then introduce stoichiometry. So this is a word map that we have them use, and they can use this on a quiz, but not on our unit tests. And what they will do is, if I give them the mass of one substance, they could find either the mass, amount of moles, or atoms or molecules, or volume of another substance, using the balanced chemical equation. Alright, so you can see on this screen we have a balanced chemical equation up top. We actually do this in a lab. So it's silver nitrate plus copper. This is a single replacement reaction. So if you put a solid piece of copper into liquid silver nitrate, a single replacement happens where the silver from the solution comes out and attaches to the solid copper. So you can see on the product side of the equation we have silver, and then copper nitrate is the solution. So we asked the students, if 100 grams of copper is reacted, how many grams of silver will be produced? So they would have to use the chart that I showed you in the previous slide and their factor labeling in order to come up with the conversions here. So we have a step-by-step, so you can see that we have, for every 1 mole of copper, there's 63.546 grams of copper. That is something that they can find on the periodic table. You can see that the grams of copper would cancel out with each other, just giving us moles of copper. Now you can get the coefficients from the moles of copper from the balanced chemical equation. So you can see that the 1 mole of copper should go down there, and on the other side of the equation there are 2 moles of silver. Alright, the moles of copper will cancel each other out, just giving us moles of silver, and then the moles of silver will cancel out, giving us grams of silver. So we can say if we have 100 grams of copper, you should end up with 402.9 grams of silver. Doing this at the elementary level might be difficult, but I think it will be possible. It would just have to be after students have learned and mastered multiplication, division, and fractions. They also must know the definitions of their measurements. So if they wanted to convert inches to miles or find out how many inches are in a mile, they can use something like this. So let's say we had like 3 inches. How many miles would 3 inches be? They could do one of the equations down at the bottom. One of the last tests that we do to see if students are comfortable with factor label is I will tell them that I am 29 years old, and I will ask them how many seconds have I been alive on this earth. Or we can do something like if the equator goes around, I think it's like 28,000 miles, how many centimeters is the circumference of the earth? So some conclusions here. The importance of units and how they give numbers a meaning, how to manipulate all units and formulas before entering in numeric values, and we try to stress that so much, and it's still kind of frustrating when students try to fly by, but we always tell them, especially when doing factor label, put in all the units first, then go back and enter in your numeric values. And this is a good way to double check all work to make sure that your units do make sense. So if I want to measure or find the volume of a classroom, well, my units should not be in centimeters squared, they should be in centimeters cubed or feet cubed. And then this is another example that we do to stress the importance of using the correct units. In 1999, NASA and Lockheed Martin were working on a Mars orbiter, and one of them used the metric system, another one used the American system for units. This messed up the navigation, actually causing the orbiter to go into a much closer orbit, destroying the orbiter. $125 million just down the drain because of the lack of coordination between the two companies and making sure that their units were in line with each other. So that's a wrap on my presentation. Hopefully this played and went well. This is my first time using Screencast-O-Matic. So there it is. Thank you.